Next, we're going to look at a type of bar chart that's actually called a histogram. And a histogram is unique in the sense that it occupies the total number of people that are between a certain range of values. Okay, in this case, their score is on a math test. Okay, and we'll go through and explain this as we carry on. So question 5a says, how many students are there in the class? And so each one of these four vertical bars indicates a certain number of students that falls into these mark categories. So there are, in this case, 3 students that are achieving a mark of between 60 and 70%. I don't know exactly what the mark is, but I know that there's 3 students that are getting somewhere between 60 and 70%. Between 70% and 80%, there's 8 students that are achieving that mark. Between 80 and 90%, there are 10 students, and between 90 and 100%, there are 9 students. Okay, so I don't know exactly what their specific marks are, but they happen to be within a certain 10-mark range. So I want to figure out how many students are in this class in total. Okay, so if I want to total it, that means I need to add those four numbers together. So 3 plus 8 plus 10 plus 9, that's going to give me the total number of students in the class. So 3 plus 8 is 11, 11 plus 10 is 21, and 21 plus 9 is 30. So there are 30 students in this particular class. So if I look at question 5b, it says how many students have a mark between 70 and 80? Well, I don't know exactly what their mark is, but I know that between 70 and 80, that's this range right here. Okay? And between 70 and 80, there are actually 8 students that have a mark of between 70% and 80%. I don't know how many they could have, 71, 72, 79, whatever, but their marks happen to be between 70% and 80%. So let's take a look at question 5c. What percent of students are achieving below 80% in Mr. Lee's math class? Okay, well, in this instance, the cutoff here is 80%. So that means that from this mark down, I want to figure out the total number of students that are achieving a mark of below 80%. Okay, so I can tell that I have 8 students that are getting between 70 and 80, and that's below 80%. And I also have 3 students that are getting between 60 and 70%, and that's also below 80%. So 3 plus 8 means that there are 11 students in the class that are achieving a mark of below 80% in Mr. Lee's math class. Next question here says, what fraction of students are achieving 70% or above? Okay, well, if I want to figure out 70% or above, let's take a look at this line. Okay, so here's my 70 line, and I want to figure out all the students who are achieving 70% or above. In this case, 70% or above, that would be 8 students are getting between 70 and 80. There are 10 students who are getting between 80 and 90. And finally, there are 9 students who are getting between 90 and 100. Okay, so 8 plus 9, or sorry, 8 plus 10 is 18, and 18 plus 9 is going to be 27. So there are 27 students who are achieving 70% or above. Now, the question says as a fraction. So 27 is just part of it. Okay, part of the class is achieving a mark of 70% or above, and that part of the class is achieving that's achieving 70% or above is 27 students. But the total number of students in the class is, as we calculated earlier in part A, the total number of students is actually 30. So there's 30 students in the class in total. Okay, and of those 30 students, 27 of them are achieving a mark of 70% or above. So we need to go through and actually convert this into a fraction in lowest terms, because this is a fraction, and that is correct, but we always want to write it as a fraction in lowest terms. Okay, so 27 and 30, they're not both divisible by 2, okay, because 27 is an odd number, but they are both divisible by 3. So if I take 27 and I divide 27 by 3, I'm left with 9. And if I take 30 and I divide that by 3, I'm left with 10. So as a fraction in lowest terms, 9 out of every 10 students in Mr. Lee's math class happen to be getting a mark of 70% or higher, which is pretty impressive.